Okay, guys, this is the third and final video in the t-test explanation. I recorded this video 3 times, or at least I thought I have recorded this video 3 times. I have to be the least tech-savvy person in the world. So I'm hoping that this fourth time does what I need for it to do, so that I can move on to the ANOVA. And I'm hoping that the lessons that I've learned in recording this video or this series of video can be applied to the ANOVA video. So we will see. Let's see what we can do here. Okay. So what I have pulled up here is just a walkthrough or the write-up for an independent samples t-test. This is very straightforward. This is the format that should be used at any and all times in writing up the results of t-test. If you have a copy of the APA publication manual, if you flip to the back there, it actually provides examples of how to write up the results from any and all analyses that you might do. And again, in having this formula, per se, it just helps to ensure that there's some uniformity in how researchers are reporting their data, but it also helps to ensure that the information is being relayed in a very clear and concise way. So I would say do not recreate the wheel, follow this example, because it's going to ensure that you have all of the data presented. It's going to ensure, or it's going to give you an opportunity to give it a second look just to make sure that it looks good, that it makes sense. So again, this is how you do it. This is what it should look like, whether you're doing it as an assignment in my class, in any other stats class, or whether you're getting ready to have something submitted for publication. Okay, so let's get started here. So basically in the first sentence, you're going to remind your readers of the type of analyses that you're doing. You're going to provide some additional information, or you're again going to remind them of the groups that you may have used, the participants that you may have used, and then what type of data, what type of numbers do you have. So we can say here that an independent samples t-test was conducted to explore the differences between group 1 and group 2 on pre and post-test scores. This next sentence I have highlighted because it's not necessarily something you will include. In social sciences research, we typically use an alpha level or p-value of 0.05. This is kind of default for us. So in that instance, you really and truly don't need to remind your readers that this is what you're doing. I would, however, suggest is that if you are using an alpha level that's different from 0.05, that you do make note of it. But again, it's really and truly not necessary if you're using 0.05. And then there's just a really quick statement in terms of where readers can find additional information about our data. So if you remember when we did the analysis in the second video, we noted that there was no statistically significant difference between group 1 and group 2 at pretest. So this next series of letters and numbers is exactly what your results should look like when you're writing them out in APA format. One of the things I want you to take note of is that your T and your P are italicized. Even here in this next sentence, our D is italicized. So you want to always make sure that any numbers that are related to the results are written in italics. Okay? So what we have here is T, and the next number we have is 18. So 18 is your degrees of freedom. So for your t-test and for your ANOVAs, you're going to have degrees of freedom noted, and we'll talk about a slight variation between degrees of freedom from t-test and ANOVAs when I start working on those videos. But you calculate your degrees of freedom by taking the total number of scores and subtracting that from the total number of groups. So with t-test, we're always going to have 2 groups. So that number remains consistent. Your number of scores, though, depends upon the number of participants, the number of scores that you have in your sample. So we're looking at pretest scores. And for group 1, we had 10. Group 2, we had 10, for a total of 20. So that's going to be 20 minus 2, and that gives us a score of degrees of freedom of 18. And then we're going to write in our actual t-value. If we look here at table 2, we'll see that t equals 0.934. And we're always round to two significant figures. So instead of writing 0.934, we'll round that to 0.93. And this is followed by our p-value. And the example that was provided in the module, and even for some of those who already turned in their homework, you can write p is less than greater than 0.05, depending upon what your results show. However, what's typical and what is preferable is that you write out your actual p-value. So Jazz has calculated this p-value for us. So we would write out p equals 0.36. Again, granting two significant figures. And then we would follow that include the reporting of our effect size. We'll talk about effect size in a little more detail in just a little bit. So this is what the write-up for the results for a pretest would look like. So moving on, we noted in a post-test that there was a statistically significant difference between group 1 and group 2. So again, following that same format, we had 10 scores for group 1, 10 scores for group 2. That's a total of 20 minus 2. That gives us degrees of freedom of 18. And then we write out our actual t-value, which is 4.98, followed by p is less than 0.001. So this is indicative, right, of a statistically significant difference. So now where our descriptive statistics come in handy is that we are able then to look at the scores at post-test for group 1 and for group 2. And at post-test, we can see that group 1 had a mean score of 32.1. Group 2 had a mean score of 25. So what we can say then is that group 1 scored statistically significant higher or significantly higher than group 2 at post-test. Or if you want to flip it, you can say that group 2 scored significantly lower than group 1 at post-test. And then we follow that with a reporting of our effect size, which is indicative of a strong degree of practical significance. So that is how we write up the results for an independent samples t-test. So let's talk a little bit more about Cohen's-d for our effect size. So we use Cohen's-d when we're comparing two groups, which means that Cohen's-d is used when we're running t-tests, whether that's an independent samples t-test or a dependent samples t-test. And it really and truly comes in handy because it helps to further explain, further clarify, and contextualize our results. So with our p-value, we let our readers know that, there was a statistically significant difference or it wasn't, but that's basically all we get from the p-value. We can, kind of dig into our descriptive statistics and see what those differences might look like. But really and truly, it doesn't tell us the magnitude of the difference that, yes, there was a difference, no, there wasn't a difference, well, what is that difference? So what our effect size does is that it helps us to determine the magnitude of the difference between those two groups, basically whether or not this really and truly means anything. So we can have results that are statistically significant, but we have a small Cohen's-d, which means that there's really and truly no meaningful, application to the real world. We can even have results that are not statistically significant, but we can have really large effect size, which means that even though the results were not statistically significant, there's still something about this data. There's still something about this information that can have some practicality to the real world. One of the things that I think about are like drug trials. So you have a pharmaceutical company who is testing a generic drug to a name brand drug. And so for them, they don't want to find any significant differences between the generic and the name brand, right? They want that generic drug to work just as effectively as the name brand drug. So we could have that instance in which there is no statistically significant difference, but then what is practical significance say, or what does our Cohen's d say the effect size says? So we can have in that instance no statistically significant difference, but depending upon what our effect size is, what our Cohen's d is, that gives us some additional information in terms of the meaningfulness of this data that we collected. So let's say we have a large effect size with our drug trial. So no statistically significant difference between a generic drug and the name brand drug, but we're looking for a medium to a large effect size Cohen's d in that research. So again, the p-value can be manipulated. As we increase the sample size, right, the larger the sample size gets, the much more likely we are to find statistically significant results, but our effect size is independent of that. So while we can manipulate p-value, we can't manipulate the effect size. So again, it gives us a truer value or truer explanation of our study results. So our Cohen's d is calculated by taking the mean of group 1 minus the mean of group 2 and dividing that by an overall standard deviation score. So very simple, very straightforward. That's very straightforward calculation. And our small effect size runs all the way up to 0.2. Our medium effect size, large effect size, you can see where those numbers lie. So again, I hope that this brief explanation or this brief walkthrough of what a reporting should look like helps. If after watching all three videos you still have questions, please feel free to reach out to me. We can come here in my office, we can hop on Zoom individually and get this figured out for you. But again, I hope you enjoyed the videos. It took me a lot of time to get things done, but I do hope that they provide some additional assistance and help for you. All right, we'll see you in the ANOVA videos.